Welcome to Trump Wire, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button and turn on notifications so you never miss an update. It's not every day we get a visitor from another star system. For most of history, we thought everything in the sky belonged to our solar system, until Oumuamua in 2017 and 2I/Borisov in 2019 changed that. Now, we have a third guest. On July 1, 2025, astronomers using Atlas in Chile spotted a faint, fast-moving smudge in the sky. Its path was a hyperbola, proof it came from beyond the sun's gravitational reach. The Minor Planet Center confirmed it the next day. 3I/Atlas, the third interstellar object ever found. This is cosmic driftwood from another star system, a sample from a distant planet-forming region. Each of these visitors is a priceless opportunity, a message in a bottle from the galaxy. The discovery electrified the scientific community. Telescopes worldwide, and even in space, pivoted to study this new arrival. What is it made of? Where did it come from? Where is it going? The clock was ticking. Interstellar objects don't linger. Astronomers had only a brief window to observe 3I/Atlas before it vanished forever. The race was on to learn everything possible about this rare guest from the stars. For a moment, our solar system was connected to the wider galaxy in a way we could see and study. Astronomers quickly calculated 3I/Atlas's path. It was headed for the inner solar system, passing close to Mars. Most agencies agreed. On October 3, 2025, it would safely fly by Mars at about 30 million kilometers. Earth was even safer, with the comet never coming closer than 240 million kilometers. For most, this was a scientific celebration, not a threat. Mars orbiters would get a rare close-up of an interstellar object. But some fringe calculations suggested a much closer approach, maybe as near as 2 million kilometers. That's close enough that a small change could have dramatic consequences. Predicting the path of a fast, unfamiliar object is tricky, and the debate highlighted the uncertainties. Most data supported a safe flyby, but the what-if questions lingered. And one Harvard professor was about to take those questions to a new level. Enter Professor Avi Loeb of Harvard, known for bold ideas, like suggesting Oumuamua was an alien artifact. Loeb and his student Adam Hibbard proposed a wild scenario. If 3I/Atlas hit Mars, it might not be an accident. Hibbard calculated that a tiny course correction in September could turn a near miss into a direct impact. Such precision, they argued, could imply intelligent guidance. Loeb speculated 3I/Atlas might be an extraterrestrial probe, perhaps designed to seed life or gather data. He pointed to the comet's unusual composition as possible evidence. Extraordinary claims require extraordinary evidence, and most scientists remain skeptical. Still, Loeb's hypothesis challenges our assumptions about what interstellar visitors could be. He urged NASA to look for fragments on Mars as possible precursors. Whether comet or probe, 3I/Atlas forces us to consider possibilities beyond the ordinary. So, what is 3I/Atlas made of? First, it's fast, about 210,000 kilometers per hour. The fastest object ever recorded visiting our solar system. That speed alone marks it as interstellar. Size estimates have ranged from 20 kilometers down to just 320 meters across, thanks to its faint, fuzzy coma. Hubble revealed a teardrop-shaped coma trailing the nucleus. The James Webb Space Telescope analyzed its light, finding a high ratio of carbon dioxide to water, unusual for local comets. It's also rich in carbon monoxide and carbonyl sulfide, suggesting it formed in a cold, carbon-rich environment. Its composition resembles D-type asteroids, rich in organic silicates and carbon. This chemical fingerprint hints at a very different birthplace from our solar system. 3I/Atlas is estimated to be over 7 billion years old, predating our sun. Tracing its path, astronomers believe it came from the Milky Way's thin disk, where most stars, including ours, reside. It's a time capsule from another world. The journey of 3I/Atlas is a cosmic road trip with a tight schedule. Discovered July 1, 2025, it was quickly targeted by Hubble for early observations. Each day, astronomers refined its path with new data. By September, it was crossing Mars's orbit, prime viewing for astronomers. This was also the window for any hypothetical course correction. The main event, October 3, 2025, its closest approach to Mars. Mars orbiters would have a front row seat. Later in October, it would reach perihelion, just inside Mars's orbit, releasing more gas and dust. After that, it would head back out of the solar system. ESA's JUICE mission and NASA's Europa Clipper would observe it as it departed, with data arriving well into 2026. Each milestone offered a fleeting chance to unlock its secrets. The arrival of 3I/Atlas triggered a worldwide scientific response. Observatories everywhere from ground to space focused on this rare visitor. The James Webb and Hubble telescopes provided early detailed insights. Mars orbiters like ESA's Mars Express and NASA's MRO prepared to track the comet during its flyby. These spacecraft, designed to study Mars, would now look outward to capture data on a fast-moving interstellar object. Multiple orbiters observing from different angles would help build a 3D model of the comet and its environment. They'd analyze the gas in its coma, confirming and expanding on JWST's findings. JUICE and Europa Clipper would add a unique perspective as the comet left the inner solar system. Back on Earth, radio and optical telescopes would track its every move. This global effort united scientists in a race to gather every possible clue before 3I/Atlas disappeared. Why all the excitement over a tiny frozen rock from another star? 3I/Atlas is a pristine sample from a different solar system, a time capsule carrying the history of its birthplace. Studying it is the closest we get to sampling the building blocks of alien worlds. Its unusual chemistry suggests other star systems may be very different from ours, with big implications for planet formation and the potential for life. These objects are probes into the galactic population of planetesimals. Their arrival highlights the need for rapid response missions, like ESA's upcoming Comet Interceptor, designed to chase the next interstellar visitor. Each object reminds us that star systems exchange material over billions of years. They could even deliver the building blocks of life, a concept called panspermia. Whether natural or artificial, 3I/Atlas expands our understanding of the universe. It challenges our technology, our assumptions, and our imagination, and it leaves us wondering what other cosmic messages are still out there, waiting to be found.